be benefiting this information because they have a less chance of exposing to the different institute and studying about this geospatial application. It is a good opportunity for the students and to learn about this geospatial technology application from the esteemed resource person. So on this occasion, I request Dr. S.K. Patnaik, Associate Professor and Organizing Secretary of this webinar, would like to give the formal welcome address.
Okay, thank you, Dr. Raja, who is the Sub-Nodal Officer of the IDP NAHEP CHA Pasighat. So, good morning to all the dignitaries and all the participants. A very good morning to all. Esteemed Honorable Vice Chancellor, Central Agriculture University, Imphal, Manipur, Dr. Anupam Mishra Sir, respected Director of Instruction, Central Agriculture University, Manipur, PI, who is the PI IDP NAHEP project, Dr. S. Basant Singh Sir, respected Dean, College of Horticulture and Forestry, Pasighat, who is the Nodal Officer of the IDP NAHEP, Professor B.N. Hazarika Sir, respected Dr. P.K. Singh, Director, Geological Survey of India, Lucknow, respected Professor P.K. Joshi ji, JNU New Delhi, respected Dr. Ishwar Chandra Das, Scientist, SG, National Remote Sensing Center, ISRO, Balanagar, Hyderabad, respected Dr. K.K. Sharma, Scientist, SG, NESAC, Shillong, respected Dr. Manoj Kumar, Scientist and in charge, FRI, Dehradun, respected Dr. Taibang Atham, Scientist, SB, IIRS, Dehradun, ISRO. Then my dear Dr. P. Raja, who is the Assistant Professor and in charge of the IDP NAHEP and Sub-Nodal Officer of CHFCU Pasighat. Respected all the resource persons, participants, students, scientists, faculties, and committee members. I welcome you all to this national webinar on the geospatial technology application in forestry, which is being conducted from 26 to 28th November 2020. Our college has conducted many webinars till date in the current COVID-19 pandemic. The topic of this national webinar is chosen specifically for the students based on the latest technologies application, space technologies application in all the natural resource management, among which forestry is one of the major aspects. So students, forestry, okay. Now geospatial technologies like remote sensing, satellite communication, navigation systems are used for varieties of applications in forestry and environment, including forest cover mapping, biodiversity characterization, forest fire monitoring, change detection, forest danger rating, wetlands, forest and biomass mapping, land degradation and desertification processes, coastal wetlands, coral reefs, mangroves and glaciers, and air and water pollution assessment. The multi-resolution satellite data like your IRS, advanced WIPs, INSATs and others, and latest satellites launched with specific objective by ISRO and other space organizations are used for historical change assessment, biomass estimation, automated annual forest changes, etc. Forest fires are routinely monitored using multi-temporal data, multi-spectral data, and near real-time satellite data are provided and also by the Forest Survey of India, Dehradun. They are continuously monitoring, mapping the forest covers and different aspects of forest. Also, Ministry of Environment and Forest and Climate Change also playing a major role in managing all these processes. Sir, for your information, 215 participants have registered in this national webinar, among which students are dominating, but still scientists and faculties have shown their interest in this seminar. So I hope all the participants will be benefited from the deliberations during these 3 days. So I do expect the participants will also actively interacted with our honorable resource persons during their lectures. I convey my gratitude to Honorable Vice Chancellor, Central Agriculture University, Impal, Manipur, for its kind help to organize these valuable webinars during this COVID-19 pandemic. On behalf of the college, I thank Director Instruction, Central Agriculture University of Manipur for its kind support to conduct such worthy seminars for the intellectuals and academicians. On my own behalf, I convey my thanks to our Dean Sir for providing necessary platform for this webinar. I thank all the resource persons who have agreed and to deliver valuable lectures in spite of their busy schedules. I thank all the participants for attending this national webinar. In the last, I thank Indian Council of Agriculture Research, New Delhi, to sanction this IDP NAI project to the university, for which we are able to conduct this such activities. Thank you all. Jai Hind. Good morning.
Thank you, Dr. Patnaik, for welcoming all the participants and other. Now, our nodal officer, Professor B.N. Hazarika, Dean, College of Horticulture, is here. He's playing a key instrumental in this project, developing a lot of institutional development activities like renovation and creating smart classroom, and he's guiding us in conducting a lot of webinars. This is our 18th webinar. So on this occasion, I request our Dean Sir to address this gathering. Sir, please.
So, well, good morning to everyone. My dear colleague, Dr. P. Raja, Dr. Patnaik, and all the NAHEP team, our most honorable Vice Chancellor of the Central Agricultural University, Director of Instruction, and all the respected resource persons all over the country, and all the viewers. So today it is a great time that under the IDP NAHEP program, we are going to organize one series of lectures on geospatial technology application in forestry. So I first of all thank all the resource persons, namely Professor P.K. Joshi, Dr. P.K. Singh, Dr. K.K. Sharma, Dr. Ishar Chandra Das, Dr. Manish Kumar, and Dr. Taibam for giving us time in this lecture series. So, as you know, under the IDP NAHEP program, our College of Horticulture and Forestry is conducting different kinds of webinar program, and today is 18th of this series, and the details already mentioned by Dr. P. Raja as well as Dr. P. Devnath. I hope during the course of these deliberations, all the viewers will be benefited upon it, and I, on my own behalf and on behalf of the organizing committee as well as on behalf of the College of Horticulture and Forestry, Pasighat, welcome everyone to this webinar program, and also thank all the resource persons for giving us time for this webinar program. So thank you very much.
Thank you very much, sir. Thank you very much, sir, for your address and encouraging the participant to partake and make use of this online webinar. Now, before starting our first session, the first session will be delivered by Professor B.K. Joshi, Professor, School of Environmental Science and ECS. He will be delivering the lecture on managing forest and forest resources, geospatial perspective. I would like to read his brief biodata. Professor B.K. Joshi is a chairperson, Social Center for Disaster Research and Professor, School of Environmental Science, Jawaharlal Nehru University, New Delhi. Prior to shifting to New Delhi in 2007, he was an Indian with the Indian Institute of Remote Sensing of a Space Research Organization for around a decade. During this, he was also adjunct faculty to the Center for Space Science and Technology Education in Asia and Pacific, an UN-affiliated institution. Professor Joshi has immensely contributed in understanding geosphere and biosphere interaction while using inputs from each observation system and geospatial technology. He has addressed some of the pressing questions related to climate change while interacting data set from the variety of land use, land cover, and glacier and precipitation and temperature regimes. He is a recipient of Indian Academy of Science and National Academy of Science of India Young Scientist Medal and the National Remote Sensing Award of ISRO and ISRO. He is a fellow of Indian Academy of Environmental Science, a fellow of Indian Geospatial Union, and fellow of National Academy of Agricultural Science. He was visiting faculty to University of Helsinki, Spring 2009, Yale School of Forestry and Environmental Studies, Spring 2011, University of Freiburg. Recently, he was recognized as KTP Visiting Fellow of University of Technology, Sydney, Australia. Sir, I welcome you, sir. Now, you can start your program. Sir, you can start your lecture.
No, sir. Sir, I think you have joined.
Sir, I made you co-host now. You can start sharing the slide. Sir, I made you co-host. Joshi, sir, you can.
Okay. So just give me a couple of seconds. Yeah. So I hope it's coming.
Yes,
Yeah,
yes,
it's coming. Slide view, you can click on to the slide
Yeah,
view.
yeah,
sir.
I will do that. Is this fine?
Okay, sir.
Yeah, it's fine.
Fine, sir.
Okay, perfect, perfect. Okay, then very good morning to all of you, and good morning to all faculty members of College of Horticulture and Forestry, Central Agriculture University, Imphal, Pasighat, and many thanks to Dr. Patnaik for getting connected and giving me this opportunity to share some of my views on managing forest and forest resources with a geospatial perspective. So what I will do is I will try taking you somewhere from basics of forest management to basics of remote sensing and GIS, and subsequently some of the applications which as a country we all are proud of, and we all are contributing to the quality science of forest management through the inputs of remote sensing and GIS. So if you look at the challenges in forest management, and these are true for country, these are true for the entire world, wherein habitat loss or endangeredness and even increase in exotic species, those have actually brought a great challenge to forest management. If you talk about entire Himalayan belt, Eupitorium is one of the most notorious species which has been seen. If you see the entire India, Lantana camara is another species which has gone to length and breadth of the country and even the adjoining countries, and which is creating a great challenge to forest managers who are working on the field. Apart from that, unsustainable resource use, and I would like to emphasize the word unsustainable over here, because resources are to be used to best of my understanding. There should be a synergy between human communities and the natural resources, wherein in the entire life cycle of resource, use is one of the very important component. But what has actually happened, that this extraction or use has gone into something unsustainable fashion, and that is creating a lot many challenges to all of us. Then because of human activities and precisely the post industrialization era, we have seen that pollution in air, water, land, everywhere, this has created altogether different kind of problem. It has got into our food chain, it has got into the entire biogeochemical cycles, and subsequently it has affected a huge forest or vegetative cover which is there on the planet. So this again has to be looked with a greater sense of responsibility, that pollution is bringing different kind of challenges to forest managers. And as we all know, and everybody prefers talking about climate change, that is a trigger event, which is precisely because of the post-industrial addition of carbon dioxide and other kind of greenhouse gases in the atmosphere, and then subsequently changes in the precipitation and temperature regimes, which has altogether given a different playground to vegetation. And as geographers say, that vegetation is the indicator of climate, so any kind of variation in climate basically affects the vegetation. Then I can keep on listing such type of challenges which are there, which may vary from geographies, which may vary from scale. But globally, if you see the population growth, which is again one of the biggest challenges, both in rural areas, in urban areas, and the mosaics of this. And this population growth has redefined our demands, which could be something very obvious if you see in from the economic point of view, but it has again redefined our desires. So from a social perspective, we see that this population growth, which could be a geographic phenomena, but it has basically affected our all kind of resources, including the forest and hence the forest management. So if you all agree with me with in these bullet points, then you should also agree with me the way forest is decreasing around the globe. We have got to understand from the many of the reports that per capita forest area in the world is 0.64 hectare, whereas if you look at India, there is a shift in decimal. People who understand mathematics or statistics, or who look at statistics carefully, they will appreciate that this shift in decimal matters a lot. And that is what has affected, forest or forest resources in the country, which has brought much more acute pressure on the forest resources. And what we got to understand, not only in India, but entire globe, your forest cover is decreasing. It is in fact, depleting because of many of the activities. One is clear felling, which appears to be, somewhere controlled by Forest Conservation Act, but practically on the ground, if you see that there are, random or scattered cases of such kind. Whereas forest degradation is something, a very common tune in forest across the country and the world, both in qualitative terms and in quantitative terms. So that kind of, mechanism is underplaying, and which is affecting the forest resources. Forests are very important, not only for our well-being, but also because these affect many of the abiotic factors, and that is probably the reason these are considered to be sink as well as source of greenhouse gases. So to manage these resources, we actually need a very reliable database or a reliable information system, which everybody is looking forward to. But before actually getting into that science, let us understand it very categorically, that based on the evidences or based on the points which I presented, human interventions are the root cause of most of the degradation which is happening around us, whether it is atmosphere, whether it is lithosphere, or it is biosphere, and in totality entire biosphere. We talk in terms of a term given by Sir A.G. Tansley, ecosystem, which is assemblage of biotic and abiotic factors interacting with each other. And to see how good any area is, you try to look at the health of the ecosystem. But probably what has happened over the period, the term which we had read in our school books as a interaction of biotic and abiotic factors, and here I would emphasize on biotic factors, they all interact with each other with irrespective of their shape, size, and many of other attributes, because there is something called energy demand. There is a law of flow of energy, as also further explained by E.P. Odum. But there are some of the social needs also wherein we get to interact with each other. But what exactly has happened, this ecosystem, it has taken a shape of something to me appears to be as ecosystem. And when I say it with a very high degree of responsibility, because most of the environmental degradation which are there, those are because of one species which has tried dominating over the entire planet. And unfortunately, that is Homo sapiens. And when I talk to, my female colleagues or my female students, I further feel very bad saying that one gender of this has tried dominating all fabrics, whether you call social fabrics, you call it economic fabric, or even other kind of professional fabrics. So this is what, according to me, this transition from ecosystem to ecosystem has actually affected most of the resources. As I am talking to forest ecologists or would-be forest managers, so I would like to depict it in much more clearer way, which is true across the tropical countries, but even for the other forest ecosystems. So you have a very clear-cut, distinct unit which is called as forest. It has an ecological definition, it has a legal definition, and it has also a dictionary meaning. In all senses, forest is something which is set aside with tree cover, with having a good coverage of different kind of flora, fauna, tier of forest. You can keep on describing forest. But truly, there is something as non-forest, wherein, human activities are predominated, and those actually get into many of the usage of services which come from forest. And in between, there is something called as fringe, which is a relatively smaller buffer zone, but that plays a crucial role. It is true in Africa, it is true in Asia, it is true in America, it is true in any of the continents around the globe, that there is a fringe which interacts between forest and non-forest. And what exactly is happening, as I said earlier also, this non-forest is trying to expand, both in terms of its demands, in terms of its desires, and also in terms of its needs. And this fringe is getting pressurized to move more towards forest. And as a result, your forest area is shrinking. And it is actually shrinking. There is a depletion of resource which is taking place. Boundaries are shifting. And because of this depletion in resource and shift in the boundary, you have, something called as exponential impact on many of the other resources, which you see as natural disasters or impact or disasters being induced by climate change or global environmental change. These forests were always very useful because they were providing unique kind of, services. People were generally referring to them as goods, timber and non-timber forest products. But lately, with Millennium Ecosystem Assessment, we have all accepted that there is something called as ecosystem services, though the term was existing since 1960s and even much earlier, but people started realizing those are provisioning services, supporting services, regulatory services, and cultural services. You go anywhere in the world, these all stand true. So these kind of things were coming from forest to fringe to non-forest, and ultimately these all were affecting forest resources. And if I wish to list, different factors which are responsible to that, so there is a whole range of, factors which are in and around human beings or needs of human beings. So this kind of, socio-ecological interaction is somewhat very true, which is law of the human existence on this blue planet, but which is affecting many of our green and blue resources. So if you further try looking at this, so it means we have altogether different type of challenges for forest management from the perspective of forest managers. So for a responsible management, you need data and you need correct analysis of that data. Again, I generally in classroom, I say if data is king, context is God. So we have whole range of data set, and some people are privileged to have much higher access to such kind of data set. But probably that data is important, but more important is the correct analysis of that data. And why do you need that data? So this is very difficult to get convinced, but this is somewhat very, very important that you should know how correctly and for what I can analyze the data. And this becomes much more, bigger challenge when your challenges are complex. And as I showed you, there are so many things which play very important role. And for a democracy like ours and many other nations, even if you provide any solution, there is a whole range of bureaucracy which finds those solutions much more complicated. So this is, challenges are complex, but for any good reason, if you are able to get access to data and you can very scientifically, technically analyze that and provide the solutions, often those solutions also appear to be very, very complicated. So we actually need tools and techniques which are very powerful. Powerful in the sense they should be able to analyze this data. They should be able to anticipate the challenges, complex challenges while analyzing that data. And when they provide solution, though they appear to be complicated, but they should be able to provide those in a language which could be very nicely implemented on the ground. And as students, you all should understand this from the not only research perspective, but also from the operational perspective. So what you need, if you actually want to handle these things, you need capable professionals. The professionals, not only professionals, but the capable professionals who can understand this data, who can analyze this with the required rigor, and which can, disintegrate the complex challenges to provide simpler solutions. And for that, capacity building is crucial. And probably, this seminar or workshop which we are having, this is part of that entire game of capacity building, which is very crucial so that we all understand the correct way of using data or analyzing data so that we can address the challenge of forest management, or for that matter, any kind of resource management. So if you all agree with me, then let me tell you some of the keys, and specifically 3 rule keys in forest data management. One is, good decision requires good information. Your entire decision making, it is basically dependent on the information. Again, I have not used the word data here, because for me, there is something as fact, there is something as data, then there is something as information, which could help us to synthesize something as called knowledge and then wisdom. So good information is needed. So when I say good information, it means data and proper processing of that data so that it can be converted into information are indispensable and integral part of entire planning, monitoring, reviewing, whether you talk at local level, you talk at national level, you talk at global level, you talk of any of the sectors, social, economic, environment, cultural, and you can keep on listing these things. So this is the first rule, to best of my understanding, that for better, good forest data management, you need good decisions which are based on good information. The second rule, to best of my understanding, is facts and opinion must be mutually supporting. It means, by processing something, I can say, oh, this is happening, that is happening, this is not good, that is not good. That is all fine, but is it is being supported or further validating the facts? That is something very important. It can be treated from different views. If you look at same data from different perspectives, that is something very important. You should be able to see your data from different perspectives, but you shouldn't misuse your data, both accidentally and intentionally. Many times people do it, while either they don't know it, and that is a mishandling of data or poor knowledge about data, or they try to manipulate it. So as a good researcher, as a good professional, you should always look at that your facts and opinion, they all should go hand in hand, and they should be correctly represented by the data which you are using. And the final is, information management and policy making and implementation are mutually dependent. Many a times we are very good at information generation. You can generate wonderful web portals, you can generate wonderful reports, atlases, maps, graphs, whatnot, which could probably help in policy making. Again, which could help in policy making, but more so the implementation is again very important. And implementation needs, better formulation, better monitoring, better assessment, better review, so that entire all phases of policy making and policy implementation could be looked at. So this is something equally important, that your information management and policy making should have a wonderful balance with your implementation. So unless you do this, whatsoever you are generating, that is okay, that is all good kind of thing, but that is not something which will be solving the problem. So herein, scientific community comes into picture. As a forest manager, people might have many questions, which are generally called as management questions. Therein, you need information, you need data which has special context and which has non-special context. When I say special context, I need to know things with respect to location, position, orientation, and many of the other quantitative parameters which come over the space. The simplest are perimeter, area, and volume, but you can always think of many other things. And these are essentially looked as these quantitative parameters or qualitative parameters are looked at as non-spatial data. So you need both spatial and non-spatial data. And to me, these become as a research questions. How can I provide this special or non-spatial need with much more concrete way? And herein, over the period, people have seen geospatial tools, geomatics, geoinformatics, or in much more simplest word, remote sensing, GIS, GPS. These provide some kind of relevant tools and information for the forest managers. So, and these things can help us. So, if you are a researcher and a professional, you should always look at, what management is looking for. If you know what management is looking for, that can help you devise your own protocols to do something. And then you can prioritize the tools and provide the relevant information and solution. This has come very aptly when people are talking about SFM, sustainable forest management. And I hope we all know, the definition of sustainable here and the necessity of that. So generally, if you look at, forest management, what do you need? You need information on biogeographical zones. You need information on climate, precipitation, temperature. You need information on ecosystem and its components, its density, type, flora, fauna, land use. You need information on edaphic factors like soil type, texture, maybe terrain, different components of terrain. You also need information on socio-economic environment, how society is interacting with this environment, or how economic policies or benefits or ways outs are interacting with this environment. And finally, resource utilization pattern. So you just don't need biotic or biotic factors. You need a whole range of, human beings and its interaction with the environment which you are talking about. And fortunately, remote sensing, GIS, and GPS helps us to understand these all kind of things. And so thus people say that, geospatial tools are something very appropriate for forest management. Let us look at, state of affairs in the country. If you look at our forest cover map, this was National Remote Sensing Agency. Now it is called as National Remote Sensing Center, a group of scientists headed by Professor P.S. Roy. In the given time period of 6 months, they were able to make forest cover map for the entire country. And people who understand computers, maps, cartographies, thematic disciplines, projections, interpretations, field visit, you can imagine, the kind of challenges they had at that point of time. And I'm talking about early 80s. Within the given time frame of 6 months, they were able to prepare such a wonderful database, which was not accepted, which was challenged, which was questioned. And it went to both lower and upper house to actually look at if this is correct or not. And the reason was very simple. This database said that we have somewhere 14 to 16% of forest cover, whereas our books were saying we have 40% plus forest cover. So this was the first attempt to create database of a national importance using remote sensing. Prior to this, no national effort was made. And because of this, repetitive doubts, clarifications, questions, they carried out the same exercise with the data set of 1980s. And they came with almost similar results, though they took the seasonal variation into account and many of the other aspects, but still the outcome was almost similar. So this, somewhere triggered that we should use technology for a resource which is very important. So then forest density was defined as closed forest, open forest, degraded forest, or mangroves. Subsequently, Forest Survey of India, which works within Ministry of Environment and Forest, and there was a gentleman, Mr. Pandey. He went to Rome. He tried looking at, how FAO is using this. We had a wonderful example from India at the behest of Dr. Roy and his team. And then they decided, let us have an institution, dedicated institution named as Forest Survey of India, with headquarters at Dehradun and representation in almost all state capitals. And you and I should be proud to say that probably we are the only country, and if you try counting, you might get another one or two countries, which is able to prepare a biennial report on forest cover. It all started with 1 million, 1:250,000, and now with 1:50,000 kind of thing. And earlier there was dense forest, open forest. Now there is very dense forest, moderate dense forest, open forest, and mangrove as a classification scheme. This document or this data is excellent when you talk about national forest cover, extraordinary when you talk about state forest cover, very, very good when you are talking about district level, and at places it is equally good at taluk scale, and in very rare spaces at village level as well. Simultaneously, aerial photographs were also talked about to prepare forest cover map at 1:50,000 scale. FSI thought that we'll be able to do it after every 10 years, at least for the reserve forest areas. Then forest stock maps came into picture, which is one of the prerequisites of forest working plan at 15,000 scale and 25,000 scale. They thought we'll be able to do it after every 10 years. But unfortunately, aerial photography couldn't take that kind of pace as satellite remote sensing came into picture. So we were not able to do it every 10 years, but for certain pockets, there are attempts which are being done. Same way, working plan, most of the divisions, they are trying to do it at 10 years, but at times it even goes for 20 years. Then you have, a World Bank supported kind of things, which were there till the aid was available. So these kind of, databases are said to be as legacy database, which are somewhat very, very important. So to put everything in right direction, we need technology, we need people, and we need data. And fortunately, countries having excellent technology. ISRO gets all credit for that, for having these satellites and providing satellite pictures. Entire youth with good understanding of IT is able to explore, such type of data sets. And India is known among best of the countries when IT comes into picture. Youth is there with 60% population. Data is there, could be, at times non-spatial, but if all these kind of things could converge into spatial information, any kind of resource management is very convenient, and very specifically forest resource management. So with this background, let us get into some basics of, and the science which we are trying to understand. So if you look at remote sensing system or science of remote sensing, you have sun, which is illuminating all the earth surface features on the ground. And when it is illuminating it, there are 4 processes which take place. When I'm speaking so many words, so many sentences and all, some of you might be thinking, okay, we have been taught this. This is of no use to us. We already know it. So you are transmitting it. Few of you might be jotting down, noting it. So that is called absorption. And some of you, what you are absorbing right now, will be emitting at the later stages in terms of your questions and all. So that is emission. And a good part of that should be reflected back. And probably because of this online mechanism, you are not able to reflect back. But I expect these bright students are interested to reflect back. And this reflection is very important. So that is what is stored by the cameras which are mounted on these satellites, and through earth stations they come on to the users. And the beauty is, data set which is collected for this blue planet by the same set of satellites with similar kind of features could be used for multi-purposes. Soil scientists, forester, agriculture scientists, geologists, geomorphologists, urban planner, you name it, and people should be able to use it. This is one of a typical diagram which you must have seen here and there. This is called as spectral response pattern, or in a much more standard way, we call it spectral signature. The bouncing back which is taking place, that is represented here along the wavelength. If you see it, 0.4, 0.8, 1.2, these are the wavelengths in micrometer. 0.4 to 0.7 is the wavelength which we all are able to see. This is a visible spectra. 0.7 onwards are the wavelengths which we are not able to sense with our naked eyes. There could be some of the organisms, some of the animals which are able to see this. Now, if you concentrate between 0.4 to 0.7, you get a unique reflectance. This is great, that is the reason we are able to see and we are able to differentiate among the things. But if you further concentrate on this, you will see that this entire reflectance pattern is summing up to 20%. Or in the sense, these all responses are so much, interlocked. And to decipher among the features, you can do, but it is relatively tedious exercise. You are able to differentiate among the things, but it is not very convenient to differentiate here. This you all should understand, Using visible spectra, you can see most of the things which are there, but when it comes to differentiating among the things, then it is slightly tedious. But the moment you go 0.7 onwards, again, you have unique responses, but apart from being unique, they are distinct apart. It means you should be able to differentiate among these things very conveniently. This is the success story of remote sensing or remote sensing in non-visible spectra. You are able to get distinct responses as within visible spectra, but you are able to discriminate them very conveniently over here. And that is what helps me to understand things in a much better way. So you gather information in different wavelengths. You have something called as slits. If you remember your physics experiments which you have done in 11th and 12th, so they are in certain ways in optics, you get to know about these slits. So you can collect information in blue wavelength, green wavelength, red wavelength, near infra, you name it, and you should be able to do it. So this is a broad range, 0.5 to 0.6, 0.6 to 0.7. You can further refine them based on the response pattern. Now, when you have collected this information, it is giving you 100% reflectance, 0% reflectance, or reflectance in between. So you have something called as gray levels. It's not black and white. These are gray levels, different shades of gray. Now you have visual units like your laptop, your mobile, your iPad, your palm top, your TV, your CCTV, LCD, whatnot. So those all work on the principles. There is something called as color guns, image planes. In much simpler, we call it picture tube. So you have RGB. If you put R on R, G on G, B on B, you get something true color. If you use an IR, so you drop something and you get something called as false color. So just for the students, it should be much more convenient to understand here. This is data collected in red band. This is in green band. This is in blue band. So these are the wavelengths in which reflectance is collected. So I call it data collected. These are my image planes, RGB. I put red on red, green on green, blue on blue. I get something called as true color composite. What I can do, I want to use an IR. The reason is very simple, because I am able to discriminate among the features in the wavelength beyond 0.7. So that is an IR. So when I put an IR on red, red on green, green on blue, I have to drop one. So I have dropped the blue one. So I get something called as false color composite. So this is my true color, this is my false color. If you see this, this is a lawn. Here you have baseball kind of stuff, some gymnast kind of stuff. These are all trees, these all are settlements and all. You get to see, wow, this is looking very good. But the moment I see in false color, everything appears as red, because near infrared is being displayed in red image plane, and that reflects very high for vegetation. But if you look at this lawn, you have this baseball, you have this gymnast, but you have these openings, which were somewhat visible in true color, but which are very evident in false color. This is beauty of false color or information collected in near infrared. There are certain things which you should be able to see, but differentiating them is very challenging. But when you look at false color, you are able to see them and you should be able to differentiate even. In addition to this, if you see these all three areas, they are appearing in probably around 2 shades of green. But the moment I see in false color composite, I see at least 4 or 5 shades of red. It means same thing is becoming much more informative. That is what, entire success of remote sensing lies in wavelengths which are beyond the visible spectra. If you collect data in that, you might get to see much more additional information, which is relatively very unlikely in true color composite. And this what people try to explore and exploit and give you something more meaningful information. So this is what images are: true color composite and false color composite. These are the wavelengths in which data is collected. But when data is being looked from space, it is able to resolve between the features. There are some people who are able to see letters from far distance. Some other set of people, they are not able to see. Then what we say, their power, the power of lenses weaker. They need additional lenses, glasses like this. So that power is called resolving power. It is 1 upon focal length diopter when we talk in terms of optics and all. Herein, in lenses, we are talking about this resolving power. So this is the spatial distance which could be resolved by the sensor. So you can see an area which is appearing very gloomy, but if you see with relatively higher spatial resolution, you see greater degree of details, further same area with higher degree of details and further. So you have somewhere, 5 meter, say somewhere 50 meter cell size, 25 meter cell size, 5 meter cell size, and as close to 1 meter cell size. So here you are able to see trees, canopies even. Here you are able to get some kind of pattern, which is granular pattern, which can tell me yes, trees are there. Here you are not getting that, but you are getting coverage. So it all depends, if you are a global scientist, you want to see entire globe in one go. For you, it doesn't matter whether there is a lawn, whether there are what kind of trees are not. But if you are very local scientist, you want to see health of each and every tree. Oh, this tree got a borer, or this is getting affected because of some insect, that kind of thing. But if you are in between, you need information somewhere as a trade-off. The best spatial resolution to my understanding is 25 centimeters, Cartosat 3, which is at the behest of Indian satellites. And then you have WorldView 3, which is having somewhere 30 centimeters. So that kind of best spatial resolutions are available. And best spatial resolution means you should be able to see each and every tree, each and every entity which is standing there on the ground. That is, you are able to appreciate. So that is, with higher resolution, you can see such kind of stuff. So you get wide range of spatial resolutions depending on what is your purpose. These all are, as I said, context is God. Why do you need data? For what purpose? That is something very important, and many a times your spatial resolution defines that, depending on what you want to achieve. This is another very interesting thing. If you see this data, this is of December 2003. Same area, January 2004. Same area, February 2004. Same area, March 2004. Again, December 2004, all red, blood red is vegetation. or dense vegetation, trees, those kind of things. These bright colors, these are bright pinkish colors, these are agriculture areas. Blue, black blue colors are water bodies. Cyan color is open area and in certain cases settlements. This greenish color is more of a grassy, wherein lignin is there but chlorophyll is not there. As a forester, you understand this. Lignin is there, but chlorophyll is not there. So within blue black, you get to see different shades. Dark blue black, it means it is very deep water. Lighter shades of blue black, it means shallowness is there or turbidity is there. Same way, redness, dark, very bright blood red, very dense canopy, open canopy, and much open canopy, and much degraded. Pinkish, these all are agriculture fields. But as I move along with months, you see that your redness is decreasing. People might say, oh, entire forest has removed. Probably not. This is a deciduous area. So your trees, they have shed their leaves. And then you are not getting any pattern of chlorophyll over there. So it is appearing like this. Same thing, if somebody clears the forest, clear felling, then also you should get to see similar patterns. But as you move to next season, new leaves are sprouting out. So that kind of thing could be looked at. Same could be in terms of water bodies. If you concentrate on water bodies, those are shrinking. At the fringes, people are growing crops. So you are getting a different cropping pattern. So some water bodies are becoming much darker, some are becoming much lighter. So we try to see these all variations, over the space and over the time. And this variation helps me to understand what exactly is happening on the ground. So people try to use data set for more than one season. And specifically for Indian conditions, wherein you do have evergreens evergreen, but lot of the area is deciduous, moist deciduous or dry deciduous. So in such conditions, you need such type of data sets. Another is GIS, Geographical Information System. In a very lighter sense, I call it GeoScasare. I hope you have seen James Bond movies. If you haven't seen, you are not enjoying your youth. You should watch James Bond movies. James Bond is James Bond because he is informed. Within his car, he has all details, sub-details. That is what makes him James Bond. If I can get similar kind of gadgets in my car, I will be James Bond, or you will be James Bond. So GIS makes you somewhat, much closer to James Bond, because anything and everything which is there on the ground could be represented as a layer, as a map on GIS environment. And if you have 20 variables, if you have 70 variables, if you have 200 variables, each of the variable could be represented as a point, line, or polygon, and can come in GIS as a separate layer. Many a times, people feel GIS is a map making exercise. It is not, it is typically a mislabeled child. GIS is not about making maps. GIS is about handling database. And I hope you all study Stat 6. So when you have Stat 6, you play with its mean, mode, median. You play with standard deviation, variance, covariance, and then you go to multivariate data analysis. So you try to dig out newer patterns, newer interpretations from that kind of data. So same happens with GIS. It handles a database which could be churned in, churned out to find out a newer kind of answers for same kind of question. That is what GIS is. As I said, you have point, line, polygon, so you have vector data. Or you have raster data. Raster data is like pixels. When you take photograph using your mobile, you zoom it, you get to see pixelated. And when you read at the back of mobile, you say this is X megapixels or Y megapixels. It means those many pixels per unit area, that what you call as resolution. So that is raster data, and vector is point, line, polygon, and all attributes is there in the table, that is attribute table. Nowadays, people keep it geodatabase. It means one file wherein everything is there, so that repetition, redundancy, retrieval, analysis could be convenient. As I said, if you have 20 variables, you have 20 layers. But for a research question, you need only 5 variables. So you pull out only those 5 layers, try putting them on the top of each other, using any of the logic, using any of the mathematics, any of the statistics, and you can get answers for your questions. And those answers could be replied in tabular format, could be replied in a graphical format, or could be replied in a map format. It means the outcome of this environment is as a map, is as a graph, is as a table. You might get a boss who is good at tables but doesn't like maps. You give him tabular data. You might get a very smart boss who likes graphs, So you give him a graphical data. And you might get a very typical map-oriented boss, you give maps as output. So you can generate any kind of output. And when I say these maps, these could be 2-dimension, these could be 3-dimension, this could be multi-dimension. You can add on as many as dimensions onto that. That is the beauty of this environment. So it makes you smart. It makes your analysis smarter. It makes you much more powerful as the tools we need. So you need relatively specific type of softwares for this. You can't do it in MS Excel or GBase, those kind of stuff. Data is paramount for all kind of things. Hardware, it's not a big deal today. You need good people to work on, those who are trained, so that you can generate wonderful applications out of that. And probably, 20, 25 years back when I started this, we were working on individual machines, computers. We had floppy, we had CD, then pen drive was not that common then. So using that, we were working on individual machines. But nowadays, everything has come into a wide range of network, and you have more of a collaborative environment which GIS is looked at. You see your Ola app, Uber app, Arogya Setu app. You talk about any of the location-based service. Location-based service means where location matters. Those all are GIS apps in a sense. So that is how people try using these kind of things. And believe me, if you are working only at a plot level and somebody claims that I'm handling national database, all these databases talk to each other. Because a common line is there, that is the coordinates. Using those coordinates, you are able to link your database. And that is generally what happen and should happen. There should be people who are working at very local scale, plot levels, or maybe range levels, or maybe division levels. And there should be set of people who are working at state levels, or maybe regional scales, or maybe federal, national scales. And these all data sets ought to talk to each other. They are bound to talk to each other. But the point is, you develop that kind of scheme wherein these are talking to each other. So you can upscale data set, you can downscale data set, and you should be able to use that. There is similar kind of stuff which is called as GPS. I hope you all know this. This all started with Department of Defense of United States. They did it for the very strategic purpose. It was the former President Clinton way back in 1998. He said that this should be made public. And since then, everybody is using GPS for civil purposes. And now most of the countries, including India, Japan, China, Russia, European Union, they all are coming with their own GPS satellites. It means the story which started with only 24 satellites or 6 orbital planes, you have hundreds of satellites which are there in different locations. And then you get more precision, much faster values, much more correct values, much more precise values. Again, it is strengthening you. But remote sensing without sensing is non-sensing. And many people do this. Why? Because they just feel, sitting in computers, painting some colors and doing some GIGO, garbage in, garbage out kind of stuff, they can generate many of the good things. So to make it sensible, you need to do something called as ground truthing. And for me, it is must. If you don't do ground truthing, and without ground truthing, ground knowledge, if you are processing your remote sensing data, you might get something very fancy, but which is not factually correct. You remember one of the rules was talking about opinion and facts. So you can opinion based on your data, but factually that might be incorrect. So ground truthing is must in remote sensing science. Without ground truthing, you might do something appearing very fancy, but scientifically, professionally, technically, almost zero. So ground truthing could be done in different ways, you know. One is I personally get down onto the ground. Second is I put my researchers onto the ground. Or I have a field staff which is there on the ground and collects the information which I need and passes it to me. So ground truthing means in any of the ways you bring the ground reality. People generally feel, you know, ground truthing is a very tedious exercise. It's not. It's very enjoying exercise. You know, I had carried out in my early stages of career, and during when I was doing research, I got opportunity to map vegetation type map for the entire India, and which made me travel all the forest ecosystems of the country. And that tells you, wow, you know, what you study in Champion and Set, you actually see it on the ground. That makes you much more knowledgeable and confident about what you are handling. You need not to go to such kind of risky landscapes. I hope you have seen this movie, you know, 128 hours. If you haven't, yeah, 128 hours. If you haven't seen it, please watch it. You know, each of the youth should watch this movie. This is extraordinarily excellent movie based on the fact, a true story. So you need not to go to such type of landscape or ground truthing. You can go to very convenient landscape, provided scientifically and statistically those are correct. I repeat, provided scientifically and statistically those are correct. That is what is very important. So let us come to, you know, applications. This is the forest cover map of the India prepared by the group of scientists, as I mentioned earlier. This is the forest cover map of the latest report SFR of 2019. See the degree of variation. See the fineness in cartographic representation. It is all technology is changing. Computers have come, better algorithms have come, and people are able to extract information in much more effective and efficient manner. This was more of a visual interpretation, which was done over the, you know, glass table. This is based on computer processing. People call it visual image processing, digital image processing. So that way technology changes. And how do you do it? You have a data set wherein you see the degree of redness, that all is forest. This is very close to you, Sonitpur. You might be knowing this, that in this time frame, a lot of forests got degraded or deforestation. So it was all red in 1994. In 1999, it was relatively gone. In 2000, it was jet. You know, it has a story. We had a researchers working way back in late 90s. So a group of co-researchers, they went to for field work to Arunachal Pradesh. And when they went in 1999, they got to see some kind of forest and all. And the next year, when they again revisited that area, they got to see, oh my God, entire forest has been cleared. And they got confused. You know, last year we came here, it was having some tree cover, but now not. Thankfully, they had GPS, they were having coordinates and field photographs. When they came back to institute, they tried looking at their earlier document, and they got to understand that, oh my God, it was all forest in 1999, and in 2000, it is all cleared. People were not knowing that. Then they looked at the historical data set and tried mapping it, and then they reported it that deforestation is taking place in the somewhere Sonitpur district, and which is bordering Arunachal Pradesh and Assam. And believe me, in that year, it was rated at the highest rate of deforestation in the entire world. This has come as a feature in National Geographic also. If you follow those magazines and all, you might get hold of that. This was the highest rate of deforestation. And this was not that they planned doing it. They went to same area in 1999, and for the research, they revisited same area in 2000. But they were vigilant. They were having documented evidences using GPS, field photographs, and they could see the satellite data. And then they discovered, I would say, discovered such kind of changes. Many a times these changes are these kind of clear felling. This could be for road construction, maybe some illegal cultivations. So any kind of geometry typology which is happening on the ground, whether geometric, corridor, fishbone, diffuse, patchy, island, those should be seen on satellite data. See this. This is a data of 1975 and this is a data of 2010. Same location. See the degree of redness which has gone. So this kind of, changes one should be able to see. Not only this, for some of the, this is Nokrek biosphere. No, this is from Odisha. So such kind of changes could be seen in other locations also. There could be reasons that deforestation is taking place. So typically what people do, they take satellite data, they try taking the seasonal data, carry out some kind of geometric and radiometric correction. Fortunately, you are getting most of the data sets from Lancet free of cost and also Sentinel. Many a times geometric and radiometric corrections are done. You do a degree of enhancement, playing with data so that you can see it much more clearly. It could be linear stretching, it could be ratioing, and then you do on-screen digitization. But remember, ground truthing is must. Without ground truthing is something, it's wrong. You also use ancillary data set, further do ground checking and make a map. Same area for time 2, you just need those vectors and put on the satellite data of time 2, carry out similar kind of analysis. But while interpreting, you just need to modify the boundaries. So that if change is 10%, your work is only 10%. If change is 2%, your work is only 2%. See this. This all was forested here. This all has got cleared. So you can just change the polygon. This was all forest here in 1991. This all 1996 non-forest. So such kind of things people do. And why these things are visible? I hope you all have gone to forest areas. You have seen canopy density, like you do stand density, bowl density and all. So canopy density looks like this. Same thing when from space somebody is looking or your satellite is looking, they are also able to appreciate this openness. And that comes in different density classes. So people make different density classes, 80% plus, 60 to 80, 40 to 60. Like I said, in Forest Survey of India, you have 4 density classes. In FAO, you have more density classes. This all depends. What is your scale of mapping and what is your objective? So those kind of things are generally done. You can also play with these bands, as I said, near infrared. I just showed you one standard false color composite. I can change the bands and the information which was not very evident over here, this has come much more evident. See this 432, 434. I'm just using 2 bands here. Here I am using 3 bands. Near infrared, red and green. Here I am using near infrared, red and near infrared. And I am able to see something different. So it is more of a, reasoning and then playing with data so that you are able to see something better, new, which is otherwise not visible. And this is how my satellite data looks like. If my density is more than 80%, it will appear all jet red. If my density is very less, all redness will go, only cyan color will be appearing. And this is what people do. So as visual interpretation was being done, when computers came, people started doing such kind of processing with computers. And as people were able to understand data set in much better way, they created their own set of algorithms or own set of, what we call it, indices to play with. And there is a model called forest canopy density model, which was developed by a group of scientists from Japan and India. And then you are able to develop such kind of density classes. And, like if you see a good photograph, you say, wow, it is beautiful. Same way, when you see a map, you don't call it, it is beautiful. You ask, what is the accuracy of that map? A map without accuracy, even 100% correct, is useless. A map without accuracy, 0% correct, is equally useless. But a map with 80% accuracy, but reported accuracy, 60% accuracy with reported accuracy is good. What is accuracy? You compare your map with ground. And then you say how correctly I have represented ground on the map. So here you have 91% accuracy. Here you have 81% accuracy. Here you have 87. See visual, though it is very controlled, you have 87% accuracy. See this FCD mapper where you are using different indices, computers and all, 91% accuracy. So it all depends, how nicely you are processing, analyzing your data, and you might get much better accuracies. As I showed you for forest cover, people also do for forest type. So this was in one of the project activity, and this module was developed wherein you take seasonal data and you do a ground truthing. While doing ground truthing, you try to monitor which are the dominant species. Then only you will be able to say what type of forest is there. Type is always defined by the seasonal variant there and the dominant species. So you need ground truthing of this order. And then you can prepare forest type maps like this, wherein you can explain phenological types. You can explain other land cover classes. So why do you need this? If you can do it on the temporal scale, like say, I have a map of 1990, 99, 2009, 2014, I should be able to see what kind of changes have taken place. As this is one of the complicated landscapes, Himalayas, Kumaon Himalayas, I believe. So that kind of, mapping could be done. See the degree of details. It is not only talking about types, deciduous, it is saying deciduous dense, deciduous open, pine, pine dense, pine open, oak, oak dense, oak open. So though mixed open, mixed dense, plantations, scrub. So such kind of details could be churned out from the satellite data. The spatial resolution is around 30 meters. You can do it for toughest terrains in the countries like Arunachal Pradesh, entire Northeast India for that matter. So this was generated in one of the research projects, DOS-DBT, which is named, and wherein such a detailed kind of, classification was done. As scientists were doing such kind of things in different institutes and all, Forest Survey of India also thought, why can't we prepare forest type map? Since 1987, they were making forest cover map, density classes. In 2010, they thought, let us make forest type map. And they used champion and state information and very intensive ground truthing. And this 14-step methodology, and they prepared the forest type map. And now they want to do it, if I am correct, after every 10 years, because type doesn't change very frequently. It is density which changes. So such kind of maps are there. See this is another set of scientists. They have, around 21 institutions. They tried making such type of information, and which is being used. And if you see this plantation, eucalyptus plantation, acacia plantation, cassarina plantation, elnus plantation, mixed plantation, name the mixed formations, gregarious formations, those all are mapped in this. So that is how, forest type mapping or forest understanding is becoming better. A newer technology has come. I hope you all know drones and UAVs. When Virat Kohli plays, so you get to see how he is keeping the bat. What is the condition of the crease? So from top, somebody is taking photographs or video for you. It happens in the marriage parties also, when there is a marriage party, a drone roars over there and it takes the photograph of all the guests. Similar kind of thing could be done in science of remote sensing. You can fit cameras which can provide you near infrared photograph, thermal photograph or indices, and you can see these locations. The spatial resolution of this is in centimeters, 2 centimeter, inches. So those kind of things are being done. That is how, very high resolution data set is being used. So now people are doing it almost real time. What do you mean by real time? You have a drone which is moving from the top. It is looking at the landscape. It is looking at capturing the photograph, which is processing, and it is telling you there are so many open areas, and from those only seeds are being dropped. And you do something called as afforestation, reforestation, those kind of activities are being done. or artificial regeneration that is being done. So there are wonderful examples from Karnataka and Haryana, Delhi, wherein drone has been used for such type of exercises. Another technology which is coming is LiDAR, when we talk about carbon, biomass, so it is not only the bole, it is entire architecture of the tree. So people want to map the entire architecture of the tree. So herein, terrestrial LiDAR is used. It drops the pulses and bounces back so that you can get to see the entire architecture. You can also do it from aerial LiDAR or space LiDAR, wherein and such kind of 3D models are being developed. And these are very useful for many of the activities looking at biodiversity gaps, forest gaps, and even estimating biomass, carbon, and all. So many people in the world, they are using it. There are some of the examples from country also. There is a professor in IIT Kanpur, Professor Bharat Lohani. He is one of the, the most equipped with such kind of technologies and wonderful know-how to carry out such kind of activities. But there are other scientific communities also which are working on this. Similar is a newer, not newer, but relatively unexperimented domain of hyperspectral. Like when you are using remote sensing, I just showed you 4 bands. It could be 7 bands, it could be 30 bands. But if your bands are hundreds, it means within blue, 10 nanometer of you have 10. Within green, 10 nanometer of 10. So you will have hundreds of bands, 200 bands, 300 bands. So people call it hyperspectral, many bands which are there. It helps you to differentiate among species, Pinus wallichina and Pinus roxburghi. You are different Terminalia species. Terminalia tomentosa, Terminalia rebec. You should be able to differentiate among those kind of things. That is the science where it is moving, and people are working very hard to develop such kind of things. Otherwise, your forest stock maps were of such kind. If you see the historic maps in some of the divisions in their older working plans, you will get to see such type of maps, which were prepared by cartographers manually. But with remote sensing, you can make much finer maps, and you can display many of the other features on that road network, maybe different kind of administrative boundaries, and people are able to enhance forest. Nowadays, most of the working plans, they are using inputs from remote sensing, whether it is a density map, type map, or even the stock map, including quality map. So people are doing such kind of things. As I said, these need, good ground truthing. When you do such type of mapping or analysis, not only satellite data, you need a very intensive ground truthing and collecting information from the ground so that you can represent things correctly. And especially when you are taking inputs from working plans and all, these kind of things become very important. But the question comes, do we want to do it for entire area, or there could be some better mechanism? As I said, you have different resolutions. You have 5 meter, you have 25 meter, or you have 50 meter. So you can see larger area using 50 meter, select some of the pockets using 25 meter, further select some of the pockets using 5 meter, generate some information here, and then extrapolate. We call it multi-stage sampling. And this is you all do, you do stratified sampling. So what you do, you carry out a stratification of your forest cover, forest type. Then you identify some location, and then further you do, sampling or plotting over there. So same thing in remote sensing could be done, and things could be much more efficient. And why people are, so much interested to map such kind of thing. This is again a wonderful example, which is from Meghalaya, 1980 map, 1989 map, 95 map, 2000 map, and you can get to know how your natural forest is getting into different forest categories or non-forest categories, because you want to know what kind of land dynamics is taking place. And if this kind of land dynamics takes place, the areas which are very intact, Nokrek Biosphere Reserve or other kind of Jaintia and Khachra Hills, which are remaining very intact, or where high dynamism is taking place. And then What will be the future? What will happen in 2010 or 2050? So those kind of predictive modeling could be done. So I just showed you for forest and non-forest. You can do it for more classes, dense forest, open forest, scrub forest. This is Dehradun, this is Mussoorie, this is Rishikesh, down here, Haridwar. So when Uttaranchal was carved as a new state, Dehradun was announced as a capital of that, we thought it will have some impact in the nearby forest cover. We tried mapping for 1990, 2001, 2006. Unlike forest, non-forest, we mapped slightly more number of classes, looked at variables like distance from road, distance from water body, distance from chains, distance from agriculture, distance from settlement. We call them as explanatory variables, the variables which explain the change. So it has come from remote sensing. Now I am taking it in GIS environment. And then using GIS environment and using Stat6, I model it for 2010 and 2015. And I get to see, oh my God, a lot of forest is going. So such kind of predictive modeling is done. We are not the new one to do it. Entire world is doing it. See 1700, 1800, 1900, 2000, how the global land use land cover is changing. So everybody is interested in doing these kind of things. The question comes, why? Let me show you another very interesting example. This is Dehradun, this is Haridwar, this is Rishikesh, this is Jim Corbett. Sorry, Rajaji. I hope you all know Rajaji National Park. This is Jim Corbett. Again, you all know Jim Corbett National Park. So now I use data set of 1990, 2000, 2005, use the explanatory variables in GIS environment, model it for 2015. Now, you all know we have the concept of protected area network. Unlike IUCN, which is protected area management, we call it protected area network. And what we believe that these protected areas should be connected. So what I am trying to see if there is a straight away connection between Rajaji National Park and Jim Corbett. So I hope you all play chess. So in chess, you have, bishop, you have king, queen, you have pawn, and for everything, there are some rules. And using those rules, you play chess. So in GIS, again, because it is a raster data, like a chessboard, I can make rules. I can say that my animal will go to forest. It will not come to road. It will not go to settlement. It will not go to very dense forest. It can go through grasslands. It can't go to deep water bodies. So those kind of things I can make rules. When I make rules, using those rules, because I have these all as layers, so I get a connectivity between Jim Corbett and Rajaji National Park. When I do it for 2015, so animal is able to move in Rajaji National Park, it is able to come out and it is lost because its rules are not fulfilling, because dense forest is not there. Maybe things have converted into agriculture, maybe open area. When I do it from Jim Corbett, it comes up to this, then it is lost. Then I make my rules lenient. I say that you can go to agriculture fields, you can go to roads, you can even go to schools and colleges. The moment I do it, I get a linkage. But the problem is this corridor has shifted 1 to 3 kilometers towards south. And animal has started coming into agriculture areas, into buildings, into around settlements. And then there is a huge amount of human-wildlife conflict. This is the problem. When you map things temporally, you understand what change is taking place, you predict it, and then you try to look into some kind of mechanism which is needed for forest management. And corridors between forest protected areas or national parks or wildlife sanctuaries is must. And if I understand this, then I can carry out some plantation here, reforestation and afforestation, so that corridor could be restored. Or I do habitat suitability. I try to look at, which are locations which are suitable for tiger, and then try to identify if I can connect these suitable patches with other suitable patches so that corridors could be maintained. Forest fire, you all know, this is one of the biggest problem in the world and including country. Entire Western Himalayas, Central India, Chota Nagpur Plateau, parts of Odisha, parts of down south, and some parts of Not always, very rare parts of Northeast India, you get to see such kind of fires. See this, this is pre-fire, this is post-fire. The color in the image is changing. And I can classify this, and then I can prepare the areas which are burned. People can also model it, to see where all the risk of fire is there. How do you model it? You look into type, you look into density, you look into terrain, you look into slope, aspect, you look into presence of human beings, road. We all know 98% of the forest fires in the world are because of human beings. Around 1 to 2% could be naturally. But there again, if you try to further investigate, you will get to see human factor is always there. It is only parts of Bruno Island, Kalimantan and all where you get to see natural fires. But across the world, forest fires could be man-made. So if you can model this, then you make something called as fire lines. And as a forest manager, you all know what I am referring to when I say forest fire lines. So for that, you need to know where incidences of forest fire could be rampant so that you can generate some type of gaps. Similarly, when you carry out some kind of interventions, you want to map those. And somebody sitting in ADB, World Bank, UNSCAP or some other agency wishes to see if your interventions are going correct or not. They can look at these satellite data sets and they can tell you, okay, there is fairly some kind of good change. If you misreport, they are like big brothers, and they can always tell you, no, your report is somewhat wrong. People even do something like this, PRA, RRA. When you get down onto the ground, talk to people, try to collect information, you can bring it in GIS environment very quickly. Such kind of things are generally very much done. Same way, nowadays, as people were doing cover density mapping and all, people are interested in something called as tree mapping, tree resource outside forest or tree outside forest. There is a huge program of Forest Survey of India and specifically for Punjab, Haryana and some part of Uttar Pradesh where they are interested in only mapping trees. There are researchers around the globe who are also counting the leaves. And you must be knowing, in Tamil Nadu, where Centrum album is considered to be one of the most precious tree, you can't cut tree without the permission of forest department. That is the law there, even if that tree is at your backyard. So it means government is also interested to know trees, number of trees and their distribution and all. So using high resolution data, people are trying to develop such kind of algorithms. So we tried with very high resolution data, wherein we can count each and every canopy using high resolution data. So you can do a degree of processing with satellite data, which is not available as a ready-made tool, but you need to generate some understanding and do that, and such kind of counting could be done. And why? Because soon people will be interested to do something called as 3D perspective of protected areas and all. In Europe and parts of US, if you are visiting some protected area, some national park or some conservation area, before getting inside, they show you such kind of things. And then they tell you, if you go on this road, $5 per ticket. If you go on this road, $20 per ticket. If you go on this road, $50 per ticket. And let's assume you have invested $50 and you don't get to see such type of landscape. So soon it will happen in India as well. I'm very much sure. And you all know the thing which has brought, all issue of tiger counting in the country. In one of the protected areas, when some visitors came and they couldn't find tiger for continuous 5 days, they actually raised it and it blew up to a stage where people were interested to count tigers. So you need such kind of tools. As I was telling you initially, invasive species, those are creating huge lot of problems. So we also try to model and map invasive species. So we try looking at what kind of distribution is there for lantana, and then try to model it, and then further do ground verification and see how correctly we are able to do such kind of things. There is a group of scientists at Ahmedabad. They are mapping tree line using historic data and the present data. And when they map it, they have said that in last 4 decades, there is a transition of 300 meters in some of the ecotones. And there is a shift in timberline. This is all because of climate change. This is all because of rise in temperature. This is all because of melting of glaciers. So if these things are true, we should be able to, model these kind of things very much. So these things are pretty decent to do, and one should be able to explore satellite data for wide range of applications which are at present or which could be there in the future. And believe me, these things are almost free of cost, which are available. Most of the softwares which could be used very potentially are freely available. There is something called as Quantum GIS, QGIS. There is something called as Diva GIS, ILWIS. The one generation of Indian scientists, those who are doing remote sensing or done remote sensing, they were trained in Netherlands. They used to go to ITC Netherlands, stay there for say 6 months or a year, and learn a software called ILWIS, Integrated Land Water Information System, and come back to India and train other set of groups. Now this software is freely available and you should be able to download. My experiment with my students tells me that if you know double click, I hope you understand double click. It is not single click of like of Facebook. It is true double click. If you know double click, you can download Quantum GIS from internet. You can spend 2 hours a day, and within 15 days, you should be able to learn GIS data processing. This, if you have no fear for computers and no fear for, special knowledge, you should be able to do it. Similar kind of things could be done using ILWIS. GRASS is another very important software, but unfortunately, it doesn't have a user interface. It comes with a command prompt, but people do it. Most of the data sets today, Landsat, Sentinel, Spot, those are freely available. If satellite has passed yesterday over your area, and if Landsat or Sentinel has captured it, it is freely available. You can go to USGS website and you should be able to download these data sets. These are openly available, freely available. You should be able to download it, process it, and carry out wonderful research. There are some of the things which are available in Bhuvan, which is at the behest of National Remote Sensing Center. For India, they have uploaded some of the thematic maps, which are land use, land cover maps in different spatial resolutions. They have DM, and for some select areas, they have other maps also. You should be able to download data sets from there. For some of the parts of the country, they also host AWIFs and List3 data, which can be downloaded. But we need to be much more generous to make data sets freely and openly available for students and researchers so that they can carry out better research and provide much better things. If you don't believe me, I request you to go to ISRI website and try to look at changematters.com. You'll get to see wonderful things, and which will be a true eye-opener to you all. The best news is now Google has come with something called as Google Earth Engine. You don't need data, you don't need software, you don't need any kind of platform. You just need laptop, computer with internet connection, go to Google Earth Engine, and if you know a bit of programming, so you can always switch over to Python very nicely and do many of the things in Google Earth Engine. This is called, like you must have heard of cloud technology. Nowadays, people talk about cloud GIS. It is as true as cloud technology, where, software as a service, platform as a service, data as a service. People call it DaaS, PaaS, SaaS in computer language. Those services are available, and you should be able to do wonderful, exciting things using space remote sensing data. Not only this, if you use Google Earth in a very judicial manner, and if you understand what you are doing, so you can do something very great kind of understandings what exactly is happening around you. See, this is an area somewhere in Andhra Pradesh in 2011. Same area in 2013. If you toggle between these two areas, here there was nothing. It was jet plain open area. Now you get to see some dots, and these all dots are very systematic. Now 2017, these dots have blown up, they have become bigger, and 2019 they have become much bigger. So what exactly is happening? In 2011 there was no vegetation, it was jet blank, similar to wasteland or open land or uncultivable land, but there are initiatives of plantation and it is growing. If you meet me in 2021, I will show you much more recent photograph and how this initiative has taken place. I hope you all have heard of CAG. You know, they give you report what has gone wrong in mining, what has gone wrong in 4G, 5G and all. They basically are Auditor General, Controller and Auditor General of India. So what they do, they also look at these kind of things. You know, if you claim excess of money that I am doing plantation, watershed management, forest regeneration, or any kind of activity, they do auditing of that. And many a times they also look at these data sets to see what exactly has happened on the ground. So this is how open source platforms could be exploited and could be used in a very systematic manner so that some good knowledge could be generated. I was asked to speak only on forest, so I kept my slides very limited to forest only. But believe me, this science is unfolding many centerfolds of domains like agriculture, climate change, disaster, energy. You know, nowadays people talk about power GIS, health GIS, urban planning, water, you name the area, and this technology has provision to make a dent there. Again, this is only with you and me that we should use this technology in a systematic manner, scientifically correct manner, so that people are able to actually use it. Otherwise, you know, um, we can always hyperbole and sell it with different kind of ways, but unless it makes any difference to the science which we are doing, or the society which we are responsible to, or the country which we are responsible to, so we'll not be able to make anything very useful. So let me come back to my forest managers again. So what you need a forest resource information system. Why do you need it? So that you can analyze and review based on data sets which are there. So as I said, you have data sets. You need some kind of policy formulation which comes through this kind of analysis. It could also take care of, you know, dissemination and use of other information. And then, as I said, it is not only analyzing it, making good maps, making good database and saying policy could be, it is policy implementation also. And policy implementation needs better analysis, better understanding of this. And once you implement it, it needs regular monitoring and evaluation. For that, again, you need a degree of data sets which can again go to a review. So it is a very cyclic process. You have to come inside the ring. And once you are inside the ring, and if you do these things systematically, you can do a very good forest management using geospatial tools, geoinformatics or geomatics. Let me tell you some of the steps which are needed for effective forest management. Earlier, I told you the rules. Now I am telling you the steps. Carry out the inventory of existing situation. Looking at any kind of data set which is available, whether it is Landsat, Sentinel, IRS data sets, Google Earth Engine, or Google Images, you try, you know, always look at looking at those data sets, compile those data sets, generate information based on what exactly is there. These all things feed into much bigger picture of national policy or national inventories and all. We here, in JNU, I am also looking after a school, special center for disaster management, in addition to my primary school, School of Environmental Sciences. Therein, we try training students for neighborhood mapping. Using such type of tools, they try to map the neighborhood and link it with disaster. You as a forester should be able to do it the forest. And once you have done that, then you plan very carefully, both short-term and long-term developments. What criteria could be there, what indicators could be there, what kind of target should I make for next 2 years, 3 years, 5 years, and how to assess cost and available resources. And each of the faculty member in forestry departments, horticulture department, should and can do this along with students. You get to see wonderful, people who are doing BSc forestry. They are excellent. They are very good. And once that is done, then you start implementation and development. It could be invest in people, invest in tool, invest in products and services. So if you can do these 3 steps, all agriculture colleges or forestry colleges or departments, inventorize, process it, and implement it. If those kind of things could be done, you can actually contribute to effective forest management. And these 3 simple baby steps should be started and could be done very nicely if you all are interested in. Because world is changing, we were always taught, people are cutting forest and forest is going. When I started reading about Himalayas, people had said that if same thing will happen, maybe entire Himalayas will go away. It's not happening. There are very good people who are taking care of resources without getting noticed. See this is a Pratapgarh Forest Division of Rajasthan. See this picture and this picture. The whole range of change, which is positive change, which has taken place. It is not that photograph is taken in different season, that is the reason it is coming like. You see the canopies, those which have come here, which were altogether totally missing. And because of that, water has also come. This is what, many people here and there are doing. This is from some other part of the world wherein, people have tried rejuvenating the forest. This is from distal globe, wherein forest resource has rejuvenated. Not only this, the area just next to us from India and Nepal, if you try comparing this kind of positive change has taken place. We all need to document such kind of changes. And these kind of changes could be documented not by national initiatives and all. These could be done by people like you and me, those who are in small colleges, small institutions and all, with group of wonderful students, motivated students, and we should try documenting and reporting this. And these all tools, data sets are freely and openly available. So let us see what is there tomorrow. Let us not regret what was not there in past. So times are changing, institutions are changing, country is changing, world is changing. We all have to take benefit of this changing times and do the best for best of the capacity building and knowledge generation. So I stop here, and if you have any question, I will be happy to answer those, provided I know the answer. If I don't know, I will openly say I don't know. So over to you, please. Yes, Dr. Raja. आपका माइक, राजा साहब आपका माइक ऑफ है.
It's 12 o'clock.
जी बोलिए।
हाँ हेलो
अब आ रही है आवाज।
So I thank Professor Joshi for excellent lecture about all the topics. So now I request all the participants, they can ask some of the questions. So now the interaction session is going on. So here Dr. Joshi is in online. So anybody is having any type of questions, they may ask Professor Joshi. So after that interaction, so we will conclude this session. So please, I invite all the participants who are interested. They can share some of the questions to Dr. Joshi, please. Hello. Okay, yep. So hello, Joshi sir, am I audible to you? Hello.
जी you are audible.
Sir, if I think any participant, you can also send some of the questions in the chat. Yes. Hello. So if the participants have no questions, so we may conclude the session with a great thank to Professor Joshi. So actually he has covered as per the lecture given to him. So nicely he has covered almost all the contents of the topic, and so he has covered actually the principles of remote sensing also, GIS also, their applications, and actually I was also going through his slides. Very nicely he has explained, and he has shown some of the case studies also, where he has done a lot of work also, and he has also covered that drones, how the drones can be used, and unmanned vehicles can be used for this monitoring and some type of mapping also, and some type of free softwares are available in the sites, and also some of the USGS sites where you can download some of the free data which will be useful, your Google Earth, and he has also mentioned about the Google Cloud. So that's why I think all the participants, mainly our students, are will be highly benefited from this lecture. So I also request sir, I can share your email ID to all the participants. If some type of questions the participants share to you, sir, I think will this we include this session. Thank you very much to Professor Joshi for his excellent lecture, and all the participants who are online to this lecture. So thank you all. Now conclusion here. So also I can share his email ID to the participants. After this, so he'll be answering our queries in time. So thank you all. So now we will have a